Question 5. A researcher wants to compare the average exam scores of students who studied using two different methods, and we're just going to call them Method A and Method B. A random sample of students is selected from each group. So, Method A, we have that there's a sample mean of 78, a sample standard deviation of 8. And notice this is a sample standard deviation and not a population standard deviation. And we have a sample size of 25. And then for method B, we have our sample mean is 74, sample standard deviation is 10, and our sample size is 30. Assume the two samples are independent. At a significance level of alpha equals 0.01, test whether or not there's a difference in the mean exam scores between the two study methods. And we're going to assume this is not pooled so that there are variances. We're going to just assume that they're not equal. Okay. So, one thing that they didn't say that we would normally need for them to say was that this is coming from a normal population. So, we got a 30 there. We're totally fine on this one. We got a 25 there. And so, generally speaking, we would want for it to have said somewhere that this is a normal population for us to be able to move forward. However, in this particular case, we're going to go ahead and move forward because we're close. We're not, but this would be like a thing if I were a researcher that I'd want to say, I don't quite have the sample size that I want, but we're fairly close. So we're going to assume these are from a normal population. Our samples are independent, and we said these are sample standard deviations. So the type of test we're going to call this is independent samples, or we could actually say that it's a two independent samples t-test. And it's going to be a t-test again because these are sample standard deviations and not population standard deviations. In terms of what we're looking for in the calculator, it's going to say 2 samp t-test. So our null and alternative hypotheses for this situation, they just said that we're looking at whether the exam scores are different in the two study methods, not if one's higher than the other. So our null hypothesis is going to be that they're not different. So mean 1 is equal to mean 2. And and then our alternative hypothesis is going to be that they're not equal. And so that means that exam scores for the first test could be higher than for the second, or the ones for the second could be higher than for the first. We don't know. This is a two-tail hypothesis test. So next step, our test statistic. We know it's going to be a t for this test, but we're going to need the calculator to go get that t. And we're going to go find our p. So in the calculator, we're going to go to the 2samp t-test. So we're going to hit the stat button, arrow over to tests, and the 2-sample t-test is the fourth choice. Because they didn't give us a list of stuff, we're going to hit stats, and then we're going to input what they gave us. So for the X1 bar, they gave us 78. For sample standard deviation 1, they gave us 8. And for the first sample size, they gave us 25. For the X2 bar, they gave us 74. For the second sample standard deviation, they gave us 10. And our second sample size is 30. Because this is just a two-tail hypothesis test, we're going to hit the not equal to. So we want the first choice. And for pooled, we're going to select no. And then go ahead and arrow down to calculate. So that's going to give us our test statistic T of 1.65 approximately, and a p-value of 0.1053. So we're comparing that p-value to this alpha value is 0.01. So our alpha is 1 penny and our p-value is 10.5 pennies. So p-value is bigger than our alpha. And so if our p-value is high, then null must fly. So we're going to fail to reject our null hypothesis. And so failing to reject our null hypothesis, in this case, if we go back and look at what we wrote for our hypotheses, we said that if we fail to reject that they're equal, that means that they're not equal. So we're going to say, if we're failing to reject it, we do not have sufficient evidence to conclude that they're different. So there is not sufficient evidence at the 1% level to suggest that there is a difference in average exam score for the two methods. So we can't say that one method is better than the other.